Welcome. In this video, we're going to use the graph of a position function to estimate the average velocity over a few intervals that I've given you here. And then we're going to use this information to estimate the instantaneous velocity at t equals 2 seconds. So let's begin with part A. And in order to estimate our average velocity on this time interval, so that's from half a second to 2 seconds, we want to find the slope of the secant line. And the slope is going to be the change in the position, so the change in s, and we're going to divide that by the change in time, which is the horizontal axis. So we're going to do the change in s, which is the vertical axis, divided by the change in time, which is the horizontal axis. So at t equals 2 seconds, the object has traveled 136 meters. And at half a second, it had only traveled 46 meters. So we're going to subtract those to find the change in position. And to find the change in time, we need to subtract from 2 seconds half a second. And this gives us 90 divided by 1.5, which yields 60. And what are our units? Well, we did the change in position, and the position was in meters, divided by the change in time, which is in seconds. So our units are meters per second. Okay, let's do this again for the interval between t equals 1 second and 2 seconds. So this is the slope, or excuse me, the secant line in question, and we want the slope of this secant line. And again, to find the average velocity, which is to say to find the slope of the secant line connecting these 2 points, we're going to find the change in position, so 136 meters. And then we're going to subtract from that 84 meters, because at 1 second this object had traveled 84 meters. And then we have to find the difference, that is the change in time, so 2 minus 1 seconds. And this gives us 52 meters per second. Please pause your video and try parts C and D independently. All right, for part C, you should have gotten 44 meters per second, and for part D, you should have gotten 28 meters per second. Now, these are going to help us find our ultimate goal here, which is to find the instantaneous velocity. And in red here, I'm going to show my work. And then in blue, I'm going to sketch the secant line connecting the 1.5 and 2 second marks. And then in orange, I'm going to sketch the secant line connecting the 2 and the 2.5 second marks. Okay, so there are my secant lines, and the reason I want those in particular is because they're the secant lines immediately adjacent to the timestamp value of t equals 2 right here. So we're interested in the slope of the tangent line at that point. And in order to find it, we're going to average the slope of this line and the slope of this line in order to find an estimate for the instantaneous velocity. So the instantaneous velocity is given by adding 44 with 28 and dividing that by 2, so finding the average of the two immediately adjacent average velocities, and you end up getting 36 meters per second. I hope this video was helpful.